Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains the difference between independent and dependent samples. Let's get started. So, two samples are going to be dependent if their values are selected from one population or somehow related or paired or matched with the sample values from another population. If there's no relationship like that you can use to pair off individual members of each population, then the samples are what we call independent. Some common examples of dependent sample data are measurements from the same subject, so before and after data. And the connection between the two populations is that you're taking data from the same person. So in the before data set, you've got a data point that's unique to one individual. And then in the after data set, you've got a data point that's unique to the same individual. So those two data points are paired together. And for each of the different subjects that you include in your before-after data sets, you have that same relationship. There's a unique value in one population that can be paired with a unique value in the other population. Matching pairs where you've got some sort of inherent relationship, like husbands and wives. So that's another example of matched data and what we would call dependent samples. So if we collect data from males and females to compare genders, that's just going to be independent because there's no one male that's necessarily connected with any one female. But if we collect data from husbands and wives, now the data are dependent because for every member of one group, there's an associated member of the other group. For every unique member of the husband group, there's a unique member of the wife group that's paired with that data point. So there's a unique relationship that's pairing unique data points from the two populations together. Now, all of this matters because our methods for hypothesis testing and constructing confidence intervals on two population means are going to differ depending upon whether we have independent or dependent samples. So what we're going to do is in the next several mini lectures, we're going to look at independent samples, and then we're going to tackle dependent samples. Before we rush off, though, we're going to take a little quiz here, a little practice to help us get this concept of independent samples down. So here's an example that you see here on the screen, and we're asked to identify whether this example uses dependent or independent samples. So our example is basically a test to determine whether smoking affects memory. So there are 50 randomly selected smokers who are asked to take a word recall test, and 50 randomly selected non-smokers who are asked to take the same test. Is this an example of dependent or independent samples? What say you? I'll give you a moment to come up with your answer. Well, I hope you said independent samples because that's what this is. There's no real relationship between any one person in the smoker group and any one person in the non-smoker group. So they're not matched up to any unique relationship, and therefore they're independent. Let's try this one. Annual incomes are obtained from a random sample of 1,200 residents in Alaska and a random sample of 1,200 residents in Hawaii. Dependent or independent samples? What say you? Again, we have an example of independent samples. You've got a group of people from Hawaii and a group of people from Alaska, but there's nothing necessarily that connects a person from Alaska with a person from Hawaii. So because there's no relationship that you can use to match individual members of each group, you're looking at independent samples. How about this one? To test the effectiveness of a diet program, 45 randomly selected subjects are weighed before the diet and 6 months after treatment with the diet. The two samples are before and after data. What say you? Dependent or independent samples? Well, I hope you said dependent samples. There is a unique relationship between every unique data point in the before group and every unique data point in the after group. And that is, you can pair them up as being data taken from the same subject. So for every subject that gave before data, that same subject gave after data. And it's that connection that you can use to match data values from each of the different groups, and therefore you have dependent samples. How about this example? IQ scores are obtained from a random sample of 75 wives and their husbands. Dependent or independent samples? What say you? Well, I hope again you said dependent samples. Okay, for every member of the wife group, there's a unique relationship with a unique data value in the husband group. And so that relationship pairs data values together and making the samples dependent. Let's look at one more example. Standardized test scores are obtained for a random sample of statistics students and a random sample of sociology students. Dependent or independent samples? What say you? Well, I hope you said independent samples, because you've got a group of stats students, you've got a group of social students, and yeah, the one's not necessarily related or has some sort of connection with the other. So therefore, you're looking at independent samples. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.